Hello friends, and welcome to you with this another video. We talk about the constraints. Everything we will talk is mentioned in this link, which is the manual of the PostgreSQL version 13. The first constraints we will talk about is the check constraint. The check constraint usually it's a very simple thing. It means that we need to check something. For instance, let's have this table. This table consists of a price of a product. Usually this price of a product, the data type of it, of this column is numeric. Numeric means it's a value, either positive or negative. Now, as we know, product prices cannot be in the negative. So when a user wants to insert data, when you want to insert the prices of these products, cannot insert a negative value, cannot give a product a negative value, a negative price. So we need to make sure that when this user inserts this value, it should not be a negative value. This can be done with the use of the check constraints. The check constraints will ensure that something will be inserted the way that we want. In this case, the price will be positive price. So the price column is more than 0, which means it's a positive value. This is the check constraints. Now this constraints can have a name. We can give it a name. It's an optional, but we can give it a name. So let's say constraint positive price, whichever name you wish to give to that constraint. Now you could have multiple constraints, and you can even compare between these two constraints. For instance, this is a price column, and this is a discounted price value. I need to make sure that the price always is bigger than the discounted price. So I can use this check constraints in here and make sure that the price always bigger than the discounted price. Now always the check constraint is of type immutable. Now you know the types of the constraints are mutable and volatile and standard. So the immutable, that means this query, no matter how many times will run, it will return the same value. That's the meaning of immutable. So how many times you will run this query, the same value we will get. This usually the check constraints is applied on the insert and the update queries, because in these situations, in the insert, in these queries, in the insert and the update, we will insert new data or update a data. So in this case, the check constraints will be applied, and we'll confirm that the inserted values are of a positive value in our case in here. Now it's not necessarily to become like this. It's not necessarily to check about it. An integer could check about anything else, string or anything else, a boolean or anything. Now the second constraint we need to talk about is the not null, which we will not talk about. We'll talk about unique that we have spoke about in the previous video. In this case, I just want to highlight two things. First thing, you can create the format to create a unique constraint for multiple columns is this one. Previously we said that we can do it like this, unique, and then down also we can do a unique, but this is true as well as you can do it in this way. The other thing is also we need to we can give the unique constraint a name, same as we did with check constraint. Now you might wonder why do we need to give names to these constraints. The issue is when you get an error, when your database throws an error, suppose in the unique, in this column, the name of the error will show this thing. So you will realize that you have an error in this column. It's just something that makes easier for you to pinpoint where is the error. That's it. The other thing is that we will talk about is the other constraint is the primary key. The primary key we have spoke about in the previous video, and in this video we will just add a few things. Now we can do a composite key, a composite primary key, This is usually used when we have a many-to-many relation. We have two tables. In these two tables, there is a relation, many-to-many. There is a cardinality, many-to-many relation. The best practice in this case is that we create a composite table, which is also called a bridge table. In that bridge table, we need to create a composite primary key, which is a combination of the primary keys of both original tables. This is how you can create a composite primary key. The other thing in the format, the other thing we need to say about is that we have mentioned this, I believe, in the previous video, but I need to iterate it again. Whenever you create a primary key, you will create an implicit unique B3 index over that table or group of columns. Sorry, over that column or group of columns. So whenever you create a primary key over a column or a group of columns, implicitly you are creating also a unique B3 index by creating that primary key. Now, there is something special about PostgreSQL. Now, in relational database theory dictates that every table must have a primary key. Every table must have a primary key. Now, this rule is not enforced by PostgreSQL, but it is usually best to follow it. This is from the manuals. This is what the manual states. The rule of every table must have a primary key is not enforced by PostgreSQL, but it's usually the best to follow it. Okay, now let's move into the next thing, which is the foreign key. Now, a foreign key, as we have mentioned in the previous video about the constraint, is a column that referencing to another column, and that column is a primary key. So we can link these two tables. So suppose that we have two tables, these two tables, and I want to link them. In this case, the primary key of this table, I will use it as a foreign key in the other table. In this way, I have created a connection between these two tables. Now, usually, as we have said in the previous video, that the foreign key should have the same type of the primary key. It is not necessary the name of the foreign key should match the name of the primary key, and it is always best that we mention not null for the primary key, so that the foreign key constraints will be applied on this column. The foreign key constraints will be applied on this column when we mention not null. Now, we also have mentioned something, and I want to update it, that when you reference thing, now let me draw your attention to one thing. This table called the referenced table. This table is the referencing table. Any row in this table called the referenced row. Any row in this table called the referencing row. Any column here called the referenced column. Any column here called the referencing column. So in the previous video I mentioned that when you reference to a column, you can mention the name of it. So this foreign key is referencing to this primary key. Now, it is not necessary to mention the name of the referenced column. It is not necessary to mention, to write down the name of the referenced column. This way it can accept normally and it will work normally. Another thing about the foreign keys is that you can also create a composite foreign key, 2 or 3 columns. You can create it and you can reference it also to another table. Mention 2 things, make sure of 2 things. The number of referencing columns should match the number of the referenced columns, and the data type of each referencing column should match the type of each referenced column. Put this in mind, otherwise you will have an error. Now let's go and talk about the bridge table and the composite table that we have speak earlier. When we have 2 tables and there is a relation, a cardinality between them, many to many, it's best practice that we create a composite table, a bridge table. This table consists of a primary key that is composite of both the primary keys of the other tables, and also it will consist of 2 foreign keys that referencing the primary keys in the other 2 tables. So there is an overlapping here between the primary keys and the foreign keys in this table. Okay, now what is the mean about this? We will talk about these things. You see, we use them in many tables. You always see on delete, restrict, on update, cascade. Now what does that mean? What is the benefit of this? And what is the meaning of it? As we have said before, the primary key is the referenced column and the foreign key is the referencing column. Always there is one referencing column pointing to a one referenced column. That's the general rule. So you cannot delete a referenced column because there is a referencing column pointing to it. So that's not acceptable, that's impossible to delete a referenced column when there is a referencing column pointing to that column. So here in the product number is the foreign key which is pointing to the product number in the product table as a primary key. You cannot just delete this column, that's not possible. So how we make sure that we cannot delete this column? By adding this on delete restrict. This will make sure that this column will not be and cannot be deleted because it is related to this foreign key. So this way we will make sure of this point. Now what about on delete cascade? What about on delete cascade? Now on delete cascade, if we delete one column, the values of the referencing row, in this table, the values of the referencing row will be deleted. This happens when we select on delete cascade. So if we delete one column here, primary, the referenced column, if we delete it, the values of the referencing row will be deleted also in this table. I hope this is clear. Now there is another 2 things, which is onset and on default. So we have on delete restrict, on delete cascade, and we have also on set, and we have on default. Now what is the onset? Onset means if we delete a referenced column, we can set the values of the row, of the referencing row, to null. If the referenced column have been deleted, the values of the referencing row shall be assigned to value null. This is the meaning of onset. What is the on default? What is the on default? That is the fourth type. The fourth type. You see here on this orders table there is a default value. This is a data type integer and the default value is 0. So supposing that the referenced column have been deleted and we are using on default instead of these two, we are using on default. What will happen? The referenced row will be replaced, the values of the referenced row will be replaced by the default value. So if we use on default instead of on delete, when a referenced column get deleted, the values of the referencing row shall be substituted with the default value. In our case, in this case, the default value is 0. So these are the things that I wish to add also on the constraints subject.